As I said, my name is Wayne Scrivens. I'm the Product Support Manager for Sandvik Loading and Hauling. And today I'm going to talk about diesel engine technologies and the opportunities to reduce diesel exhaust emissions. Now, firstly, safety is the number one priority for us at Sandvik when we're designing our mining equipment, which means what we're introducing is the latest technology available to our equipment to reduce diesel exhaust emissions. Now let us look, firstly, diesel exhaust emissions comprise of both gaseous emissions and diesel particulate matter. So let us look at these different emissions in detail before we start looking at the technologies. Firstly, you have carbon monoxide. Now, CO is created when there is not enough oxygen present in the combustion chamber during the combustion of diesel fuel in a diesel engine. The CO is highly toxic and in very low concentrations, and at very high concentrations it can be lethal. And then you have nitrogen oxides, NOx, which consists of both nitrogen dioxide and nitric oxide. Now, nitrogen oxides are generated from the oxidation or burning of nitrogen, the most abundant gas in the atmosphere. It's typically formed when there is a very lean fuel-to-air ratio, a lot of oxygen content inside the combustion chamber, and also at very high temperatures. In particular, NO2 is highly toxic in low concentrations and can damage the lung tissue. Then you have carbon dioxide, CO2. Now this results in the oxidation or burning of the carbon in the fuel. Now because of CO2 production correlates very well with fuel consumption. And CO2, when breathed in by humans, can cause headaches, dizziness, and can be toxic at high enough concentrations. And then finally you have sulfur dioxide. Sulfur dioxide is formed from the burning of sulfur, which is present in the diesel fuel. It is highly toxic at very low concentrations and damages lung tissue. As it is breathed into the lungs, it reacts with moisture to form something like sulfuric acid. And then we have diesel particulate matter. Diesel particulate matter is formed from the incomplete combustion of diesel fuel in the combustion chamber. It was classified as a carcinogen by the World Health Organization in 2012, as it has been linked with lung cancer, respiratory problems, and heart disease. Underground miners are potentially exposed to much higher levels than other occupations. This is because there is less air underground to dilute these particulate matter emissions, and also they can get picked up by the ventilation system carried throughout the mine. Whereas on the surface, they would typically settle on the ground. So let us look at some of the ways to which we can reduce the exposure of miners to these emissions, whether they are gaseous emissions or diesel particulate matter. Firstly, one way to reduce exposure to diesel particulates is to use enclosed cabins and filtered air conditioning systems. Now, as standard on our cabins for our loading and hauling equipment, we use a Class 5 filter system to European standard EN 779. This filters 40 to 60% of particulates greater than 5 micron. The cabin is also pressurised to prevent the ingress of particulate matter and dust by any other means other than the air conditioning filter. The advantage of this is it controls the amount of dust and particulate matter that the operator is exposed to. but it doesn't prevent any exposure to miners outside the cabin. Another way to reduce exposure to exhaust emissions is to use low sulphur diesel fuels. Low sulphur diesel fuels reduces the formation of sulphur dioxide and also the formation of diesel particulate matter. When the sulphur burns in the combustion chamber, it can also get into the lubrication oil and down into the oil of the sump of the engine. What this then tends to do, it becomes acidic and it breaks down the lubrication properties of the oil. So this can then lead to more wear on the engine. So when you're using higher sulphur fuels, you need to change the oil interval so that you're changing the oil more regularly. The other thing is that new low emission Tier 4 engines require ultra low sulphur diesel fuel, as the sulphur dioxides that are produced from the burning of the sulphur poison the exhaust after treatment system. In order for us to introduce new engine technologies for lower emissions, many countries have now made ultra-low sulphur diesel fuel mandatory or compulsory. They have limited the amount of sulphur content that is allowed in the diesel. The maximum sulphur content for ultra-low sulphur diesel is between 10 to 15 parts per million of sulphur, which is equivalent to 15 milligrams per kilogram. Now what we show here is a map showing the maximum sulphur content that is allowed by different countries and laws around the world. Now you'll be able to see here that the ultra-low sulphur fuel in the light blue, it's been introduced to be able to introduce new diesel engine technologies in Europe, the United States, Japan, Korea and Australia. Now, ultra-low sulphur diesels may still be available in many of the other countries, but there is a risk that these fuels can become contaminated by higher sulphur fuels that are allowed through both storage and transportation. And this really is the biggest challenge for CIS countries, for us introducing new diesel engine technologies, as fuels with much higher sulphur content are still being used and are still allowed to be used. Exposure to diesel emissions can also be reduced by using low emission engines. In order to reduce off-road diesel emissions, the United States Environmental Protection Agency, the EPA, and the European Union, EU, introduced emission regulations in tiers or stages. These tiers or stages limit the maximum exhaust gas particulate matter emissions and gaseous emissions that can be produced by a diesel engine. Tier 1 began in 2000 for the engines that we use, and we have now moved to Tier 4 in 2014. The engine emissions are measured under an 8-mode cycle test for the certification, and then the weighted average emissions are calculated, and they need to fall in within the tier envelopes shown on this graph. You can see on this vertical column we have the maximum allowable diesel particulate matter. We have the maximum allowable NOx. So for Tier 1, the emissions of the engine has to fall within the green envelope. For Tier 3, within the orange, Tier 2 within the orange, Tier 3 within the red. And we come all the way down to Tier 4A, which is Tier 4 interim, and Tier 4B, commonly known as Tier 4 final. We can see from these results that the allowable particulate emissions has dropped by 90% when you go from Tier 3 to Tier 4 interim. And you also lower the NOx emissions by 40% when you go from Tier 3 to Tier 4 interim. And then when we go to Tier 4 final, we've seen a further 80% reduction in NOx compared to Tier 4 interim. Sandvik introduced the Tier 4 interim engine into our 5600 series loaders and trucks in 2011. We are now offering the Tier 4 final in 2014. The engines that we use are 13 litre and 16 litre engines from Volvo Penta that incorporate an SCR exhaust after treatment system. SCR is the acronym for Selective Catalytic Reduction, and I'll go through how that system works in a little bit more detail. Firstly, the Volvo Tier 4 engine requires ultra-low sulphur diesel and a urea solution, commonly known as AdBlue. The AdBlue is put in a separate tank and a pump is used to inject it into the exhaust gas stream. The base engine is tuned with a very lean fuel-to-air ratio, which produces extremely high NOx, but a very, very low diesel particulate matter. But this also makes it very, very fuel efficient. The AdBlue is injected into the exhaust gas stream and it reacts with the NOx in the SCR catalytic converter. So basically you get a chemical reaction where the NOx emissions are oxidised to produce nitrogen, which as I said is the most abundant gas in the atmosphere, and H2O, water. Now this is very much proven technology as it has been around and used by Volvo in on-road trucks since 2007. The reason we like this solution is that unlike some other Tier 4 engines, there is no externally cooled gas circulation, EGR. Now this means that there's no additional cooling capacity required by our radiators to cool this exhaust gas that gets recirculated back into the engine. So we don't have to make our radiators bigger, we don't have to make our loaders and trucks larger, and we can still fit in the same tunnel space. The other thing to note with this solution is the base engine is very similar to a Tier 2 engine using the same technology. So it's very simple and easy to maintain because it's simple to what we already use now. So what we've done is, in the case of our LH517, we have combined our low emission Tier 4 engine with a loader designed for the optimum power to payload ratio and optimum power to weight ratio. The advantage of this combination we have seen is a significant reduction in fuel consumption. Our LH517 consumes up to 20% less fuel than our other competitors in the 17-tonne loader class. Now, as I said that fuel burn correlates with CO2 emissions, we are also lowering emissions, and we're lowering the CO2 that we produce. On top of that, we are seeing significant fuel savings, but lowering operating costs, and potentially we could lower ventilation costs. So let's look at this in a little bit more detail. So we're almost 7 tonne lighter than other machines which carry the same payload. The advantage of this is that we can use an engine with much lower power, 285 kilowatts compared to over 230 kilowatts. In addition, we also use Tier 4 engines, which is extremely fuel efficient. It only consumes 216 grams per kilowatt hour compared to 224 or 226 for a Tier 3 engine. So as a result, our Tier 4 LH517 consumes 20% less fuel than our competitors. If we base our average duty cycle on 50% rated power, we are consuming 37 litres per hour compared to 45 in our competitors. If you then look at an average number of hours of 4,000 hours per operating year, we're saving about 32,000 litres of fuel per year. In this comparison, for a cost per litre of $1.35 Canadian dollars, that equates to approximately $43,200 per year. And we don't have access to ultra-low sulfur diesel, and we can't use Tier 4 engines. The next best option is to use a Tier 2 or 3 engine plus exhaust after-treatment systems. So let's go through what some of these different types of exhaust after-treatments are, and we'll explain to you how they work. Firstly, you have a diesel oxidation catalyst. An oxidation catalyst oxidizes CO to CO2 emissions. As I said earlier, CO is highly toxic in very small concentrations, so it's desirable for us to oxidize the CO into CO2. Typically, an oxidation catalyst can reduce CO emissions by 80 to 90%. And this is now standard on all of our Sandvik loaders and trucks. It's fitted into the exhaust muffler. Another type of exhaust after-treatment system is the diesel particulate filter. Diesel particulate filters capture diesel particulates to prevent their release into the atmosphere. They typically replace the existing exhaust muffler. I'll go through some different types of diesel particulate filters in more detail. Firstly, there is the flow-through particulate filter. Now, it has a particle oxidation catalyst that can reduce particulate matter by 40 to 50%. The advantage of this system is that it flows through and cannot get blocked. It's more difficult to get blocked with diesel particulate matter or soot. The disadvantage is that it doesn't capture all of the soot and all of the diesel particulate matter. And then we have wall flow filters. Now, wall flow filters can trap up to 99% of diesel particulate matter. This trapped matter must be oxidized at very high temperatures for a filter to clog. So the diesel particulate matter is trapped in the filter, and you need to have high exhaust gas temperatures for it to burn off. Now, typically, exhaust gas temperature is elevated when an engine is working under very heavy load. But if the engine is not running under load for long periods of time, the exhaust temperature will not get hot enough to be able to burn off the trapped soot or diesel particulate matter. For very fast regeneration or burning off of the soot, the exhaust gas needs to be up close to 600 degrees Celsius. Unfortunately, most diesel engines do not have exhaust gas temperatures which get this hot. So what we need to do, as you can see in this graph, if the exhaust gas temperature is lower, we need to expose the diesel particulate matter to those high temperatures for longer periods of time, and the filter can become blocked. Even if your particulate filter is working correctly, not all of the diesel particulate matter can burn. So the particulate filter has to be regularly removed and cleaned, as it needs to remove the ash, which is incombustible. With a particulate filter, you need to understand the duty cycle of the machine and how it will operate. And if I give you an example for a truck underground, when it's fully loaded, travelling up a ramp, is under heavy load, and you have very high exhaust gas temperature. This is then burning off the soot that is captured in the particulate filter. And once we get to the surface and the loader is dumping, typically hydraulic systems don't pull as much load from an engine. So the exhaust gas is not as hot, but it's still developing diesel particulate matter that is trapped in the filter. Then when the truck turns around and it goes underground, once again, it is travelling back empty. It is not under a lot of load. exhaust gas temperatures are not very hot, but it's still producing diesel particulate matter that is trapped in the filter. And then when we get underground, the truck is idling as it's waiting for the loader to load the box. Once again, it's a very cool exhaust gas temperature, but it's still generating diesel particulate matter. So we have to have that balance and ensure that the engine is under load for the right amount of time to be able to burn off the soot that is collected when the engine is not under load. So how do we prevent diesel particulate filters from becoming blocked if we can't get that really high exhaust gas temperature to be able to burn off the soot? One method is to use an oxidation catalyst in front of the diesel particulate filter. It basically converts NO to NO2, nitrogen dioxide. This nitrogen dioxide then oxidizes the trapped carbon inside the particulate filter. The advantage of this is that you're having a chemical reaction that can actually happen at a much lower exhaust gas temperature. You don't have to work the engine so hard all the time. The disadvantage of this method is it will increase NO2 emissions if there's not enough carbon actually trapped in the filter for it to have a chemical reaction. And as we said before, NO2 is highly toxic in low concentrations, so we need to ensure there's the right balance between generation of particulate matter and NO2 emissions. The other thing is this sort of solution requires ultra-low sulfur diesel fuel, because the creation of sulfur dioxide will react with the oxidation catalyst and poison the catalyst, making it ineffective. Another method for reducing filters from clogging and becoming blocked is to use what we call a fuel-borne catalyst. Basically, fuel additive is put into a separate tank and it is dosed into the fuel tank. It mixes with the fuel and it burns inside the combustion chamber. So it's very different to selective catalytic reduction. Now, as the additive burns in the combustion chamber, it adheres itself to the diesel particulate matter. When the diesel particulate matter is then trapped in the filter, it burns much faster at lower exhaust gas temperatures. In most cases, exhaust temperatures above 380 degrees Celsius for around 10% operating times will make this filter work correctly, which is quite achievable for a diesel engine. The other advantage of this type of solution is that diesel fuel with 50 to 500 parts per billion sulfur can be used in this system. So it makes this more suitable for countries without ultra-low sulfur diesel fuels. And this system is currently being developed by Sandic for our big loaders and trucks. Another very important way to reduce the exposure of diesel exhaust emissions is to establish emissions-based maintenance. Engines must be routinely measured, engine emissions, sorry, should be routinely measured, and the engine should be repaired if the emissions start to increase. This also includes replacing dirty engines prior to them failing. Now, engine emissions can increase from a number of different factors, and I'll explain a few examples. Firstly, if an air filter or exhaust muffler becomes blocked, that can increase carbon monoxide emissions as well as the diesel particulate matter emissions. If injectors are worn or are faulty, then that also can increase either particulate matter or nitrogen oxide emissions. If the engine coolers become blocked and the engine overheats, not only does that reduce the life of the engine and cause wear, but it also can increase NO2 emissions and NOx emissions as the charger after coolers become blocked. And finally, contaminated fuel with water or dirt can wear components in the engine, and that will then increase exhaust emissions as well. Ventilation is another control that can be used to reduce the exposure to exhaust emissions. ventilation is used to dilute gaseous emissions and particulate matter. Now, traditionally, many countries multiply the rated diesel power by a regulatory value to then give the minimum airflow requirement for one diesel engine. However, this method doesn't consider modern low emission engines, because with this method you would have the same ventilation rate for a Tier 4 engine compared to a non-tier engine. In reality, airflow requirements may be reduced by using a Tier 4 engine or a Tier 2, 3 engine with exhaust after treatment systems. Here are some typical examples where the rated engine power is multiplied by a value, a regulatory value, to give the minimum airflow requirement. You can see here in New South Wales, Australia, we multiply 0.06 for our example of our LH517, which has a power of 285 kilowatts, and this requires 17.1 cubic metres per second of airflow, or this is equivalent to 36,233 cubic feet per minute. You can see that these values vary for different countries around the world, and from what I've seen for CIS countries, if you try to achieve 5 cubic metres per minute per horsepower for this particular engine, you would require 68,511 cubic feet per minute of airflow, which is very, very high. In Canada, the ventilation is calculated to dilute the gaseous emission to below what is called the threshold limit value. Now these TLV values are given on the right. So these are the maximum allowable values for emissions after they have been diluted by the ventilation. And you will see that for nitrogen dioxide and sulfur dioxide, as I mentioned before, they need to be diluted to very low levels because they are highly toxic in low concentrations. The engines are tested in an 8-mode cycle test, similar to what the Environmental Protection Agency does, and the emissions are measured. The minimum ventilation is then calculated to dilute the worst gaseous emission that was measured. They then calculate an exhaust quality index from a combination of different gases and particulate matter emissions. We have CANMET certification for our Tier 4 engines in our LH517 loader. And the results of this testing show a 40% reduction in the ventilation requirement for this Tier 4 engine in our 517 compared to other 17-tonne loaders in this class. I'll show you the results. And you can also see that the LH517 Tier 4 engine requires 40% less ventilation compared to other competitors. In the US, the same 8-mode testing cycle is carried out and the ventilation is calculated to dilute the worst gas to their threshold limit values. And these values are also shown on the right-hand side of this slide. What EMSHA also do is they calculate the airflow required to dilute the particulate matter emissions down to 1.0 milligrams per cubic metre. This is then used as a guide for mining companies to select the cleanest engines that are available on the market. For the case of our LH517 with the Tier 4 instrument engine, the particulate index is 90% lower than its equivalent competitors, which I'll show you in the next slide. The EMSHA ventilation rate is shown on the left-hand side, and the EMSHA particulate index is shown on the right. The ventilation rate for the LH517 Tier 2 engine is governed by the worst emission, which is NOx. What you'll also notice is that the Tier 2 engine has a very similar ventilation rate to the Tier 3 engine. Now this is because we use a smaller engine with lower horsepower, because we require less horsepower because our machine is lighter to be able to provide the same performance. Now a diesel engine without any exhaust after treatment cannot produce both low particulate matter and low NOx. There has to be a trade-off between the two. So you have either high NOx, low particulate matter, or low NOx, high particulate matter. Now, our Tier 2 engine has been tuned to produce slightly higher NOx, but still give a very good ventilation result compared to our competitors. But the advantage is the Tier 2 engine produces less smoke, diesel particulate matter, so it has a lower particulate index. And then you can see the Tier 4 interim engine. It is tuned for extremely high NOx and very, very low particulate matter, but it has the SCR after treatment system to then treat that NOx. So you can see that we have a 90% reduction in particulate matter emissions for a Tier 4 engine compared to other engines used in this loader class. While the actual ventilation requirements are actually governed by carbon dioxide emissions. Now remember we said that carbon dioxide production correlates with fuel burn. So what this means is we can't make this engine any cleaner and lower the emissions without reducing the amount of fuel that's consumed. As I said earlier, the minimum ventilation for our Tier 4 engine is governed by air required to dilute the CO2 emissions. Now, since CO2 emissions correlate with fuel burn, the best way to reduce that ventilation is to try to reduce fuel power, engine power, and fuel consumption. Now, this may be possible in the future using diesel-electric hybrids. Now, how a diesel-electric hybrids work are, a diesel engine runs at a constant speed and it drives a generator. This generator produces electricity which charges a battery on board the loader or truck, and then it drives electric wheel motors. Electric wheel motors can be used for braking the vehicle, and the energy that it's used can be stored in the battery, which can be then used later on during operation. This also, electric wheel drive motors and hybrids have much higher efficiency than our conventional torque converter and mechanical transmissions. So there is potential to be able to lower the required diesel power because it's a lot more energy efficient. And consequently, by lowering the size of the engine or the power required, we lower CO2 emissions and potentially further lower ventilation. So we can set the engine up to run at its optimum speed for very, very low fuel consumption. And because it's running at a constant speed, you almost eliminate any transient emissions, transient smoke or soot. And those of you who will know with the diesel engine, a turbocharged diesel engine in particular, when you accelerate a diesel engine from a standing position, you get turbo lag, where fuel is injected into the combustion chamber. There is not enough air being produced by the turbo, and you get diesel particulate emissions until the turbocharger speeds up and provides enough air. By running at a constant speed, we are eliminating these transient smokes. And then, obviously, in the future, the best way to reduce diesel emissions is to actually eliminate diesel altogether and replace them with either battery or fuel cell power. The challenge with this technology is we need the battery to be small enough to be able to fit in the loader or truck and to be used underground, but it must be able to store enough energy for us to go through the loading and hauling process without having to recharge the battery too often. So what are the opportunities for reducing diesel exhaust emissions in CIS countries? Now we've discussed there are a number of methods for reducing the exposure of diesel exhaust emissions in CIS. We have enclosed cabins, we have Tier 2, Tier 3 engines, which can run on higher sulfur fuels. We have oxidation catalysts. We can provide good preventative emissions-based maintenance, good ventilation practices, and where possible we can use electric loaders to eliminate diesel altogether. Today we have Tier 4 engines available and different particulate filter technologies. But in the future, ultra-low sulfur diesel fuel is really the most critical thing to introducing these new engine technologies into the CIS.
Dobre utro. My name is Martti Virtanen. I'm working as product support manager in sandwich loading and hauling product area, and I'm based in Turku. I'm going to talk to you about selection criteria for underground loaders and trucks, and after that about electric power underground mining loaders. Safety is number one in Sandvik, and first I have a couple of examples of how we protect the operators in our machines. Here you can see the picture that was taken in Mexico. There was a massive rockfall. Unfortunately, this loader was remote controlled, so there was no operator in the cabin. But you can see that after the unit was digged out from the rockfall, the cabin formation was still quite good, so maybe the operator would even have survived in this kind of accident. Then I have a video clip about how does it work, this video? Standard ROPS cabin, so it can take quite well such a rockfall. Maybe in the practice the result would be even better, because normally the cabin is on rubber tires and needs some extra suspension. That's about safety. Factors. There are half of the things that can be affected by machine design and machine features, but all of them can be affected by the mine or operator. If you think the loading area layout, it's only can be affected by the mine. When it comes to the material loaded, the specific weight of the rock, it is what it is, but with fragmentation, with blasting, the mine can control the specific weight of the broken material. Bucket filling factor, it depends on both the features of the loader and the skills of the operator. Cycle time, there is a tramming distance which is defined by the mine, but bucket filling time and tramming speed, there both the machine design and the operator has the effects. And then same for reliability of the machine, but again utilization that only depends on the mine. But generally it can be said that 60%, around 60% of the loading performance depends on the operator or on the mine. So it's very important part, but still this 40% which comes from the loaders plays a big important portion. If we think loading application, different loading application, and what are the cost and capacity factors in those applications. First, like block caving, sub-level caving, where the draw point loading is used. There normally the driving distance are short, and the major capacity factor is the bucket loading, bucket filling. And also major cost factor is bucket filling. In ore pass loading, which means secondary loading, there besides the bucket filling, also the hauling distance plays an important role when it comes to the capacity. And but still the major cost factor is the bucket filling, and I'm coming back to that later. In open stope mining, the maneuverability of the loader inside the stope is the critical capacity factor. Very often this loading is done by remote control, so really there is how the loader moves inside the stope is the critical capacity factor. When it comes to development, tunneling, then the working arrangement are the major capacity factor. The loaders normally work with trucks, so it depends how the trucks are available. Do the loaders have to wait for the trucks? Are they idling? So this plays main role in the capacity. But again, the different damages are the main cost factor. In Sandvik LHD load haul dump machines, our design philosophy has two main focusing areas. One is the safety and economic operations and maintenance. It means that we fit always this, as we saw, this strong ROPS, FOPS protected or standard protection canopies or cabins in our machine. There are always seatbelts available for the operator. We pay a lot of time to make the visibility of the operator as good as possible to increase the safety. We use vibration, low vibration seats and soundproof cabins to make the operators' conditions as good as possible. Maintenance, the ground level maintenance is also one of the basic requirements. Besides of those mentioned on the list, fire safety is very important, and we put a lot of effort to make our machines as fire safe as possible, since underground fire is always a major risk or major danger. So there are fire suppression systems available. We locate the different hydraulic components on the cool side of the engine to reduce the risk of fire. Besides safety and economic operation, the other important area is productivity of the loader. And productivity of the loader, high productivity of the loader can be achieved only by having very efficient bucket filling, so that the operator can fill the bucket very fast and properly in one pass loading. Tire life and other component life will be much longer if the loading can be done efficiently. And then if there are oversized borders, good loading capability makes possible to handle those as well. I have other video clips, and this proper bucket filling is a combination with good features of the loader and good skills of the operator. If you don't have enough power on your lift cylinders and to lift the bucket, you have to tilt it, and then the machine starts to clean on the rock pile, and the bucket is not filled properly. Once again. Then another important thing is the physical size of the loader. I'm talking later about the selection of electric loader versus diesel loader, but if you just think the size of the loader, normally the tunnel dimensions put the limit of the loader you can use in that specific case. There are local regulations defining the free space between the tunnel and the machine, so those have to be taken into account. Then there are sharp corners, so you have to make sure that the loader has enough small turning radius to be able to drive through those places. And then one thing is if you have a shaft mine where there is no decline, and the machine often has to be dismantled before taking it down into the mine. Then you have to make sure that it can be dismantled in so small pieces that it can be taken through the shaft. And then if the loader is operating together with the truck, the match has to be good enough. So the loader has to be able to load the truck, and the lift height is then often the important thing. Here you can see a dimensional drawing of one of our loaders. So the important diameters are, of course, the height, and then if you are using truck loader, high enough to make it. Oh, sorry, I can't work with this. Sorry. Sorry. Okay, it's this button. So you have to make sure that there is enough space to empty the bucket into the dump of the truck. There are also open ventilation pipes and other infrastructure things in the tunnel, so you have to take into account that the machine can still fit in the tunnel without damaging those parts. And then the turning radius must be good enough to operate in the shaft kernel. There are two different volumes according that the standard defines. There is so-called rated capacity, which means the heated bucket load, and that's the one that we use, and that is the one who practically shows the capacity of the loader. The other one is strut capacity. It just defines the water volume of the bucket, and it it really cannot be used for selecting or calculating the packet size in this kind of application. But you have to notice that never select a machine based on the nominal packet size, because first you have to select the loader so that it suits in your operation, in your tunnel size, and then you can have different choices for the packets. There are always more than one packet size available for our loaders. And here I have an exercise what should be taken into account when the packet size is determined. In this exercise, we have a specific gravity of the ore, 3.9 tons per cubic meter, and the swell factor is 60%. 3 dimensions, 5 by 5, and in this case the loader is loading the 50-ton truck. And there are no tight corners that puts the limit to the loader size. Tramming distance is 100 meter or less. If you have a look at the tunnel size, in 5 by 5 meter tunnel, all the LHCs from 517 to smaller ones can fit in. So that's the maximum size of the loader you can use. But because in this case it was question of truck loading, the ideal size is this 517, 17 tons loader, since it can fill the dump box of 50-ton truck with 3 packet loads, and that's the optimal choice very often. Optimal match, 3 packet loads for 1 dump box. You can get the broken density of the ore by dividing the in situ gravity with the swell factor. So in this case, the broken density is 2.44 ton per cubic meter. And if you divide the capacity of the loader with this broken density, you end up to the optimal bucket size, which is in this case 6.97 cubic meter. Then you can select what is the closest one from the available buckets, and in this case it's obviously 7 cubic meter bucket. So what I'm saying, it's important to use the specific gravity of broken rock to define the bucket size, in order not to overload the machine and to get the optimum size of the bucket. LHC. The ownership cost, the capital cost, although it's important, it's not the most significant of the cost. Just 1/3 part of the total cost in the lifetime of the loader comes from the purchasing price. The rest is coming from the operating costs. And the main items in operating costs are fuel, tires, and bucket. So the important thing is, when selecting the loaders, not just to compare the prices of the loaders, but to try to get information what are the total costs, and not only the costs, then you should also take into account how capable the loader is load, because the only things that matters are the cost per ton, not the cost itself, but the cost compared to the work what the loader is capable to do. If we have a look the loader operating cycle, so it's there are big differences how the different components are stressed during the loading cycle. Then in a typical loading with 100-meter tramming distance, if we have a look how the components, from where they wearing and stress is coming in that loading cycle, then 70%, this is all the time.
Don't worry about it, Mark.
This is all the time moving this one.
Yeah.
Sorry, I should have a different laser pointer. Okay. Too big finger. So 70–80% of the stress of the wearing is happening during the loading. The others doesn't pay that big importance. So this again shows that if you can make the bucket filling very fast and efficiently, you can really prolong the lifetime of the loader. You can increase the productivity, the loaded tons per certain period, and in the same time you can prolong the lifetime of the loader. So the bucket filling is extremely important feature of the loader. Example, how different changes in bucket filling affect to the total capacity. In this first example, we have a loading distance, hauling distance, 300 meters, the specific gravity of the ore, 1.8 tons per cubic meter, and then the cycle times is so that 40 seconds is used for bucket filling, 10 seconds for dumping the load, and 15 seconds for different kind of acceleration, turning the machine, and then the tramming speed during the tramming distance, average tramming speed 7 kilometers per hour. And the bucket size 3.3 cubic meter and bucket filling factor 0.8 is 80%. In this way, in 200 days operation, this loader can load 234,000 tons. In the second exercise, everything else is same, but we have a little bit more better loader and better operator. So instead of 80%, the bucket filling factor is 90%. All the rest is same. But with this increase of 10% of bucket filling factor, the capacity in 200 days is increasing 30,000 tons, 12.5%. That's 10% difference in bucket filling factor. And in the third example, the operator and the machine is so good that the bucket can be filled in 30 seconds, 10 seconds less than in the other two examples. And in this way, this 200 days capacity is increased to 276,000 tons. So if the machine can fill the bucket properly, 10% more better filling factor, and make it 10 seconds faster, the capacity, annual capacity or capacity in 200 days can be increased almost 20%. And in the same time, this machine is under high stress and load considerably shorter period, which means that the lifetime of the components will increase. Then we talk a little bit about truck selection. In trucks, there is not such a thing as in loaders, it's bucket filling. So in structure, the design philosophy is still the same when it comes to the economy and to the safety. But in order to get the highest productivity, the power, the engine power ratio compared to the dead weight, the own weight of the machine, this has to be optimal, which means that the dead weight of the machine has to be made as low as possible without compromising the robustness of the machine. So there, smart design is needed to put the steel in the correct places, not making the own weight too big, but making the machine strong enough. Then, in what it comes to the truck selections, there are very many things that affect. First of all, the tunnel size is defining the maximum size of the truck you can use. But then there are other things like number of the loading points and flexibility. You have to drive in many different places with your trucks. So these are also things to be taken into account. What I mean that if you select the biggest possible truck to fulfill the capacity needed, production capacity, it's not always the optimum choice if there are so many different loading points that should be operating in the same time. So in that case, maybe it's better to select a bigger number of machines, but then you end up to another thing that you have to take into consideration. If there are big number of machines, it may cause a traffic jam on the big decline. So you have to take into account all these things to find out the optimal size and the optimal number of the trucks. And still there is one more thing. If you are using a LHC loader to load the truck, the match between the loader and the truck should be optimal. In many cases it's 3 bucket loads to 1 dump box. Then there are other tasks like unloading the truck. If the truck is unloaded underground, you have to make sure that there is enough height in the tunnel to be able to tip the truck. Or you can use a special push plate, we call it ejector dump box, where the unloading can be done without tipping the dump box. Then you have to take into account for what purpose the machine is used. Is it for production, for development, for backfilling, or for all of them? So there are many things that affect in selection of trucks. Of course, also operating conditions like ambient temperature, the ventilation, available ventilation, even the altitude where the machine is working, they has effect to this selection. In the truck, the distribution of operational costs are a little bit different compared to the loader, because in truck it's question of hauling and the machine is operating at full power if it's a ramp hauling. All the time when it's driving from the bottom of the mine up to the surface or to the next level. So there the fuel consumption is it's more important than in loaders. Ventilation. So the importance of clean engines is important because there are sometimes ventilation problems since the engine is operating at full speed all the time, more more ventilation is perhaps needed. But there is not just where operational cost as loaders. We have a bucket that is wearing all the time. Dump box is of course wearing, but it's not wearing so heavily. So fuel is important, and that makes very important to keep the weight of the machine, the own weight of the machine, as more as possible to reduce the fuel costs. Here we have one example where we have 3 different trucks. There is 15 tons, 20 tons, and 40-ton trucks, and needed capacity to be moved by the truck is 850 tons in a year. And there is quite short, vertical distance is 500 meters, and it's 1 to 7, so means that running distance is something like 3.5 kilometers. And here we have used the same figures when it comes to the loading, turning, and these kind of things for all trucks. But then this running distance, running speed on the ramp, it's taken from the tractive effort capability of the unit. So this is the highest speed that each of these trucks can achieve on 14%, which means 1 to 7 ramp. And then we have calculated the number of needed trucks, and it shows that to get this 850 tons annual capacity, 14 pieces of these 315 trucks are needed. And the same capacity can be reached by 6 of 30-ton trucks. So if it's a purely question of getting that much transported, I think that this bigger truck is better choice, because 14 trucks on one ramp can cause a lot of disturbance to each other, and maybe cycle times will be increased because trucks has to pass themselves on the ramp. Then I'm going to talk about electric loaders. Common application for electric loaders are the mines. Loading is done in a fixed loading area, and that's typically in case in the mass mining operation, like in sub-level caving or in the block caving, where the loaders stay in the same area for months and months. It's important that there is no other traffic in the LHC road, because there is this grading cable, and it can't be driven over other equipment. Besides this mass mining, there are electric loaders are often used in the cases where ventilation is difficult to arrange, and those are room and pillar mines and cut and fill mines. So the clear benefits of LHC loaders are that there are no exhaust emissions, no exhaust gases at all. But they have also other no, it's this one. This is mine. No. Yeah, but this one is not correct. Yeah. So yes, there are other benefits as well. They generate less heat, they are quiet, they generate less noise. but they are only capable to work in the limited area, so in most cases the tramming distance has to be less than 300 meters. They have less maintenance because there is not electric diesel engine that has to be maintained. Electric motor is quite service free. It doesn't need any maintenance. So low noise electric loaders, our electric loaders are just something like 70, 72 decibel noise level, and heat can be reduced quite a lot. There's less maintenance, less waste oils, and lower energy cost. Of course, that depends on the prices of fuel and electricity, and there are differences in different areas. But generally, electricity is cheaper than the diesel fuel. And one of the benefits of electric loaders is that the electric motor doesn't have any such a diesel lag what diesel engine has, which means that it responds when you want to accelerate, it responds immediately, and also electric motors can be overloaded for short periods, so you can get 50% more power out from the electric motor compared to the nominal power, which means that in bucket loading, which is a short period, you can get 1.5 times the power of the nominal power of the electric motor, which makes it very efficient in loading. Here are some McKinsey consultants' estimation how the energy cost will develop from 2010 to 2020 in different countries. And in most of these countries, these example countries, diesel fuel is expected to be, diesel fuel price is expected to increase much faster, much more than the price of the electricity. So this will make the electric loaders even more or less the operation cost of electric loaders even more competitive in long run. This is an example from Barrick Gold, one of their mines, where they have listed the energy cost. Energy consumption and energy cost in a year, and you can see that something like 40% of the total energy is consumed underground operations, and some major part of that is used for ventilation, primary and secondary ventilation. So ventilation is very, very big cost item in underground mine operation. Ventilation need of diesel and electric loader is very different. There is no diesel particulate, there is no diesel emission in electric loaders, so there is no ventilation needed for those purposes. There is some heat coming, but not so much as from the diesel unit, so the ventilation need because of heat generation is much smaller. And here we compare the 14 tons electric loader and 14 tons diesel loader. You can see that the nominal power of electric loader is much less, but as I mentioned, you can overload the electric motor by 50% for a short period, so actually you can get the same power out from the electric loader as you can from the diesel one when it's needed, and it's needed only when filling the bucket. According to this Canadian institute, CanMet, this diesel loader 514 with Tier 2 engine requires 20,500 cubic feet per minute ventilation, and per hour it costs about $30 Canadian dollars. So if the machine is operating 3,500 hours, the cost is over 100,000 Canadian dollars. Then there is a comparison of energy costs. Due to this overloading of electric motor, the average load of electric engine is a bit higher, but the nominal output is smaller. So when calculating with these energy prices, which are quite okay with the European prices, I'm not quite sure how the prices are in CIS, but 1 kilowatt hour costs something like 8 cents, US cents, and diesel fuel $1.1 US. So I think that those are quite valid figures. You end up to the result that the energy cost of per hour of electric loader is just 25% of the cost, energy cost of the diesel loader. So it makes a huge difference when operating, for instance, 3,500 hours, almost 100,000 US dollars. If you think maintenance, in electric loader you have cable, reel, and electric panel, what you don't have in the diesel machine. But in diesel machines there are much more maintenance items that you don't have in the electric loaders, like you have to fully fuel it, refuel it once a shift. There is engine oil that has to be changed regularly, air cleaners, you have to check the emissions, exhaust temperature has to be checked, radiators and coolers have to be cleaned regularly, and so there are plenty of maintenance things you have to do with the diesel one. And if you think the relative operating cost, so the differences are here. But in diesel loader you have different engine and engine-related items that you have to do, and you have much higher fuel cost. So the operation cost difference is roughly 20%, depending on the application. But or electric loader is cheaper to use. What? 5 minutes. To go. Okay. Yeah, I will do it. Okay, then the summary of the cost. There is a big saving in fuel cost, big saving in ventilation cost, and even the maintenance costs are lower. So savings per year with electric loader can be very, very big. In this special case, something like 270,000 US dollars. And then you can also get higher production because you don't need to refill the machine. Normally you have to do it with the diesel one once in shift, and you have to do some daily added service. So we made a calculation that this is a copper mine where the ramming distance is 200 meters, and in normal shift you can operate with the electric loader 1 hour longer, 6.6 instead of 5.6, because you don't have to refill it, you don't have to to the daily, so much daily maintenance. So this is a copper mine, so the price of copper is something like $7,000, $7,600, and the grade of copper is 0.8%. So we calculated that with this 1 hour difference in effective shift hours, what is actually the value of the metal in the ore, what you can mine in 1 day or in 1 year, which means 300 days. So by this 1 hour longer, that the copper value of that ore is over $10 million higher. Of course, that is not your savings, because you have other processing costs for the ore. You have to smelt the ore, you have to concentrate the ore, so it's not the savings. But in this kind of operation, your turnover can be this much, your revenue can be this much bigger. The profit is not that much bigger, but it really makes a big difference, this 1 hour shorter maintenance and operation. Electric loader is an efficient high productivity machine, but it doesn't fit for all operations. The layout has to be correct, and there has to be electricity available in the mine. The running distance has to be short enough, or if you need to move the machine, for instance, to the workshop or out of the mine, you need special equipment like generator sets or towing equipment. Then you need skilled electricians. So there are limitations, but if you have suitable conditions, you really can get a big benefits from electric loader. Thank you.
И поблагодарить руководство и сотрудников фирмы «Сантрик» за предоставленную возможность выступить перед вами. Темой моей презентации будет комбинированный способ нагнетательного проветривания и всасывающего обеспыливания при проходке подземных выработок. Моя презентация будет состоять из 3 подразделов. Это введение, директивы требования, система обеспыливания и вентиляции, расчет параметров обеспыливающих установок и вентиляционных установок, а также подведение итогов. С 1990, немножко коротко нашей фирмы, с 1999 года фирма CFT, продолжая более чем 50-летние традиции и опыт фирмы предшественницы Хольтер GmbH, успешно внедряет передовые технологии, предлагает, разрабатывает и производит как системные решения, так и индивидуальные подходы по обеспыливанию и проветриванию, вентиляции в туннелестроении и горной добывающей промышленности в многих странах мира, в том числе в России, Украине, Республике Беларусь и Республике Казахстан. Обеспыливание при ведении проходских работ, снабжение проходских забоев свежим воздухом в процессе строительства туннелей или горно-добывающей промышленности требует весьма детальной проработки, тщательного проектирования и качественного изготовления необходимого оборудования, чтобы подача воздуха, обеспыливание всегда соответствовали высоким требованиям производственной безопасности, охране труда, охране здоровья людей и охране окружающей среды. На этом слайде я хотел бы вам представить, показать наше обеспыливающее вентиляционное оборудование, примеры применения. В основном здесь указано туннельное строительство. На этом слайде вы видите туннелепроходский комплекс, оборудованный обеспыливающим вентиляционное оборудование нашей фирмы. Это наше обеспечивающее оборудование при строительстве туннеля. Это наше обеспечивающее оборудование при реконструкции подземных коммуникаций во Франкфурте на Майне, то есть как метро, то есть U-Bahn. Это то же самое. Это, вы видите, портальные вентиляционные установки на проходке туннелей в Сочи при строительстве Сочи 2014. Это то же самое. И на этом слайде, на этой картинке указаны наши мобильные контейнеры исполнения электрокалориферные вентиляционные установки для подачи нагретого воздуха при строительстве стволов. В данном случае строительство ствола на руднике Волгокалий, это город Котельник. Теперь коротко направление деятельности нашей фирмы. Производство, реализация обеспыливателей сухого, мокрого действия и их комплектующие для тоннельного строительства и горнодобывающей промышленности. Производство, эксклюзивные права на реализацию силовых вентиляторов и их комплектующие фирмы Кортман, Люфттехник ГmbH Германия для местного главного и портального проветривания, для оснащения ими обеспыливателей нашей фирмы, для применения в туннельном хозяйстве, в туннельном строительстве и горнодобывающей промышленности. Эксклюзивные права на реализацию гибких, плоских и спиральных вентиляционных труб, их комплектующих фирмы Schaumburg, туннель вентиляционный ГmbH Германия для проветривания туннелестроения и горнодобывающей промышленности. Эксклюзивные права на реализацию оборудования для охлаждения воздуха, их комплектующей фирмы ВТ Wärme Austausch Technik ГmbH Германия, а также реализация электрокалориферного оборудования для нагревательных выработок в горнодобывающей промышленности. И вот эти 6 фотографий, то есть показывают, как оно и что бывает на самом деле. Теперь, с вашего разрешения, перехожу к второму пункту моей презентации. Одним из важных требований относительно безопасности персонала, машин и механизмов производственной безопасности, охраны труда, охраны здоровья людей и окружающей среды являются требования. Это достаточный расчетный объем необходимого свежего воздуха, который подается в груди забоя. Кроме этого, оптимально расчетный объем очистки обеспыливания загрязненного воздуха. Выбор вентиляционных и обеспыливающих систем базируется на указанном перечне международных основных нормативных документов. Вот. Перечислять я сейчас их не буду, вы сможете это все прочитать. Это первые, скажем так, БГ, БАУ, СИА 1196, БС, технические правила по опасных веществах, директива ЛОБа. Это все наши нормативные документы Европейского Союза. И последний приказ, правила и наказ – это нормативные документы, которые существуют в России, в Казахстане и в Украине. И теперь я хотел бы остановиться на следующем слайде. На следующем слайде, то есть основные выдержки из этих документов, то есть то, что, скажем, в первую очередь, на что нужно обращать для того, чтобы выбрать правильную систему обеспыливания и проветривания. Значит, первое – это объем доли кислорода. Объемная доля кислорода по общепринятым стандартам должна составлять не менее 19% от общего объема воздуха, который подается. Значит, влияние веществ опасных по здоровью. Уже мои предыдущие коллеги говорили, что это и окись углевода, окись азота, двуокись серы, тонкодисперсная пыль. Кроме этого, следующее – это эмиссии дизельных двигателей и агрегатов. Здесь нужно учить следующее. Значит, двигатели и агрегаты без фильтров, улавливания частиц сгорания, без регулярного контроля выбросов. В данном случае нужно рассчитывать следующее, что номинальная мощность подачи воздуха при очистных работах и загрузке горной массы должна составлять 6 кубических метров про минуту на каждый киловатт дизельной техники или механизма. Номинальная мощность подачи воздуха при транспортировке горной массы, укреплении, бетонировании горных выработков должна составлять не менее 3 кубических метров в минуту на каждый киловатт мощности дизельной техники. Двигатели и агрегаты с фильтрами улавливания частиц сгорания с регулярным контролем выбросов. Здесь нормы немножко ниже. То есть получается, для очистных работ и загрузки горной массы должна составлять мощность подачи воздуха не менее 4 кубических метров в минуту на киловатт мощности дизельного агрегата. И при транспортировке горной массы и укреплении бетонирования горных выработок должна составлять не менее 2 кубических метров по минуту на каждый киловатт мощности дизельного агрегата. Вот. Эти требования, видите, там у меня есть такая маленькая звездочка, эти требования, которые здесь мной указаны, это согласно директиве законодательным нормам по странам Европейского Союза. К сожалению, я не могу сказать, какие нормы, скажем, России или бывших республиках Советского Союза, но исходя из этого, то есть я вам показываю, как оно должно на самом деле быть. Ну, для людей в данном случае можно сказать так, что максимальный объем воздуха, который необходим в туннеле или в горной выработке, 0,1 умножить на количество людей, которые одновременно работают в смене или в течение суток. Это и получается кубический метр в минуту. Но это какой-то дополнительный. Теперь следующий параметр – это скорость воздухопотока при проходке горных выработок. В общем, в самом большом свободном течении горной выработки от 0,15 до 0,5 метров в секунду скорость воздушного потока. При буровозрывных работах скорость воздуха составляет, то есть минимальная скорость воздуха больше или равна 0,3 метра по секунду. Это согласно швейцарского нормативного документа СИА 196. Значит так, в подготовительных выработках и на нарезных выработках, это согласно законодательным документам Российской Федерации, Казахстан, Украина, минимальная скорость воздуха больше равна 0,25 метра по секунду. При наличии взрывоопасных рудничных газов, например, метан, тогда получается, что минимальная скорость воздуха больше или равна 0,5 метра по секунду в очистных забоях. Если посмотреть эти нормативные документы, там еще ряд других показателей, о которых я сейчас не хочу говорить, то есть и не буду говорить, потому что вы сами знаете, какие есть другие нормативные данные в ваших документах. Теперь переходим к другому пункту, это нормативные данные по содержанию пыли. Максимально допустимая концентрация, поскольку нормы по содержанию пыли в сфере горной промышленности, в частности при добыче каменного угля, регулируется не только максимально допустимой концентрацией на рабочем месте, но также графиком работы персонала под землей. Поэтому различаются два показателя. Максимально допустимая концентрация вредных веществ для кварца, ранее составляющая 0,15 мг на кубический метр воздуха, была отменена. Это имеется в виду в Германии и в Западной Европе. И кварц зачислен в категорию канцерогенных веществ. В настоящее время обсуждается снижение максимально допустимой концентрации до значения 0,5 до 0,1 мг на кубический метр воздуха, запыленного воздуха, скажем, полевого воздуха. Значит так, второй пункт – это значение максимально допустимой концентрации тонкодисперсной пыли, частицы которых меньше или равны 10 микрометра, способны проникнуть в альвеолы легких, составляет 3,0 мг на кубический метр запыленного воздуха. Но как раз вот эти частицы, о которых вот в втором пункте сказано, они вызывают, вызывают болезнь силикозом у людей, которые работают под землей. Хочу коротко сказать, что в Германии, так как я там живу и работаю, в Германии с 1900 не буду брать, с 1979 года на угольных шахтах, на рудниках, которые еще работают и существуют в Германии, не было зарегистрировано ни одного случая заболевания силикозом работников, которые постоянно находятся под землей. Вот. И для соблюдения данных норм необходимо снижение пылеобразования в целом. Это совершенно верно. Так, теперь переходим к третьему пункту моей презентации. Это система обеспыления и вентиляции. Вот. Здесь, на этом слайде, я остановился на 3 основных видах проходки. Это проходка комбайном избирательного действия. Вот там комбайн, это обеспыливатель. Теперь проходка тоннельно-проходским комплексом. Здесь тоже установлены обеспыливающие установки, вентиляционные установки. Ну а также буровзрывной способ ведения горных выработок. Сейчас мы остановимся на нагнетательное проветривание при системе обеспыливания. Здесь вот как пример, схемка. Здесь мы видим, скажем так, портальный вентилятор, вентиляционная установка или вентилятор местного проветривания, вентиляционный став. Здесь можем припустить, что здесь находится или буровзрывной способ, или комбайн работы в данном случае. Следующий недостаток. Создаваемая в процессе проходки пыль, это и при буровзрывных работах, и при работе комбайновым способом, и при помощи ТПК, тоннельно-проходского комбайна, беспрепятственно вымывается наружу туннеля, скажем, горной выработки, пространство горной выработки. Вот. Вымывается при помощи портальной вентиляционной установки или вентилятора местного проветривания. И если здесь внимательно посмотреть, вы видите, как вот эта вся пыль из туннеля, в данном случае из туннеля, она выходит наружу. В данном случае, скажем так, это уединенное место, где нет жилых домов, скажем так, где не находятся люди, здесь, в принципе, ничего страшного нет. Вот такая атмосфера существует внутри проходки туннеля. Эти фотографии я делал лично сам, когда приезжал на приемку эксплуатации нашей техники. Вот такая ситуация находится. Но это вам не нужно доказывать, вы сами знаете. Вот. Нарушаются требования техники безопасности и охраны здоровья работающего персонала. Создается также опасность преждевременного выхода со строя и электронного оборудования. Потому что вы сами прекрасно понимаете, что новая техника, которая работает в туннелях и горнодобывающей промышленности, она начинена как электроника, как электрика, и поэтому все это пагубно влияет на ее работоспособность и укорачивает срок годности, скажем, срок работы этой техники. Ну и, само собой разумеется, замедляется значительно технологический процесс проходки горных выработок. Это само собой. Вот. На следующий, это тоже как пример, нагнетательное проветривание при системе обеспыливания, то есть проходка в системе колота-штроса с применением вспомогательных вентиляторов местного проветривания. То есть бывает, если длина туннеля, скажем, горной выработки достаточно велика и мощности портального или местного вентилятора не хватает, поэтому ставят промежуточные вспомогательные вентиляторы. Это как пример. Теперь мы перейдем к следующему слайду. Здесь так называемое всасывающее проветривание через систему обеспыливания. В данном случае мы видим сам обеспыливатель, вентилятор или вентилятор, который находится уже с чистой стороны. Здесь вентиляционный став, который выводит уже очищенный чистый воздух, выводит наружу из горной выработки. Какой недостаток этой системы? Могу сказать следующее, что большое потребление электроэнергии электродвигателями вентиляционных установок, которые находятся совместно с обеспыливающим оборудованием. Эту систему нужно оборудовать не систему, а, скажем так, эти вентиляторы нужно оборудовать очень мощными двигателями, чтобы преодолеть потери давления как в всасывающем патрубке, как в самом потере давления, которые возникают в самом обеспыливателе, потери давления, которые, чтобы вытолкать, скажем так, просто в народе, чтобы вытолкнуть этот воздух по вентиляционному ставу. Кроме этого, нужно учесть, что во время проходки здесь находятся механизмы и оборудование, которые постоянно там или временно работают, которые тоже создают сопротивление воздуха, который самопроизвольно идет к груди забоя. Вот. Кроме этого, и поэтому нужно соблюдать эти все нормативные данные, чтобы соблюсти эти нормативные данные по минимальной или максимальной скорости воздуха, продвижения воздуха по самому туннелю или горной выработке, значит, на это нужно обращать внимание. Кроме этого, значит, если мы засасываем загрязненный воздух через обеспыливатель, его обеспылим его наружу, значит, нам необходимо также есть такие требования к обеспыливающей установке, чтобы скорость воздуха в всасывающем трубопроводе или воздухопроводе должна быть не менее 20 метров в секунду. Если она будет менее 20 метров в секунду, то есть вот эта пыль, которая находится в составе воздуха запыленного, она будет потихоньку оседать в этом ставе, соответственно, сужать стечение этого става, ну и, соответственно, производительность этой обеспыливающей установки снижается, и она не делает то, для чего она рассчитана. Вот. Теперь мы переходим, следующий слайд говорит о комбинированной системе нагнетательного проветривания и всасывающего обеспыливания при проходке комбайновым способом. На вот этих фотографиях, видите, это что было и что стало. Это одно и то же. Это один туннель, могу даже сказать, это Сочи, вот, вентиляционный стал, и у портала находятся наши вентиляционные установки. И вот, как видите, вся пыль находится только в районе работы рабочего органа комбайна избирательного действия. Я потом вам покажу. Значит, здесь чтобы какой-то более понятнее, что где находится. Здесь находится портальная вентиляционная установка или вентилятор местного проветривания. Вентиляционный стал, гибкий вентиляционный стал. Здесь находится так называемое перфорированное или шлицевое устройство для создания вихревого потока, называется вихревой поток Коанда. Это я потом вам расскажу, что это такое. Ну, здесь находится обеспыливающая установка, ее вентиляторы и всасывающий патрубок. Вот эти все обозначения 10 метров, это, скажем так, это был определенный проект, поэтому на них не надо обращать внимание. Если необходимо будет более какие-то детальные подробности, уже мы можем встретиться после моей презентации, об этом поговорить. Вот. И мы здесь видим, при работе комбайновым способом, расчетный объем отсасывания запыленного воздуха, это нормативные данные. При работе комбайна избирательного действия мы должны рассчитывать так, что 25 до 30 кубических метров в минуту должны мы отсасывать запыленного воздуха на каждый квадратный метр сечения горной выработки. Это есть такие стандарты, и вот в пределах 25-30 метров мы можем передвигаться. Тогда у нас получится очень высокая производительность самой обеспыливающей установки. Обеспыливание воздуха будет осуществляться, будет придерживаться требованиям нормативных документов, и обеспыливающая установка, скажем, нашего производства в этом случае будет достигать степени очистки воздуха, запыленного воздуха 99,98 при концентрации пыли в 1 кубическом метре запыленного воздуха до 5000 миллиграмм. Это сухого принципа действия. Мокрого принципа действия 99,64 при таких же исходных данных. Это у нас комбайновый способ. Следующий слайд – это комбинированная система обеспыливания и проветривания при проходке туннеля проходским комбайном. Это называется накопитель вентиляционных труб, обеспыливающая установка. И в данном случае при работе ТБМ нормативный расчетный объем отсадки запыленного воздуха должно составлять примерно 10 кубических метров в минуту на каждый квадратный метр сечения горной выработки. Сейчас я немножко на следующем слайде хочу вам рассказать немножко сам принцип работы этой комбинированной системы проветривания и обеспыливания. Как пример сечения выработки примерно 16 квадратных метров. Вот. В данном случае комбайн не работает. Мы ВМП, имеется ВМП, это вентилятор местного проветривания или портальная вентиляционная установка, подает снаружи воздушный поток непосредственно к груди забоя. Струя воздушный поток возвращается обратно. Вот. Здесь указаны размеры, как располагается всасывающий патрубок, где заканчивается конец вентиляционного става при подаче воздуха. И теперь мы видим, здесь накопитель вентиляционных труб, или как называют аккумулятор вентиляционных труб. Здесь так называемая перфорированная или шлицевая труба для создания эффекта Коанда. Это я покажу в последующих примерах. Здесь находится, скажем так, воздушная заслонка с пневмоприводом или с воздушным приводом, или с гидравлическим приводом. Это обеспылющая установка, всасывающая гофрированная труба, или спиральная вентиляционная труба для всаса пыли. И это вентилятор с чистой стороны обеспылющей установки. В случае, когда комбайн начинает работать и рабочий орган начинает разрушать горную массу, возникает как пыль, само собой разумеется. В этом случае воздух, который подается через вентиляционную установку, доходит до перфорированной вентиляционной трубы, при этом заслонка закрыта, и воздух приходит через нее. И за счет завихрения команды создается так называемая пылезащитная, пылепрожимающая стенка, которая движется непосредственно к груди забоя. И одновременно при этом работает вентиляционная обеспылющая установка. Она, этот весь воздух, который запыленный и прижат свежим воздухом, этой стенкой, этой пробкой, он поступает непосредственно через обеспылющую установку и потом выводится, уже очищенный, выводится наружу, складывается с той разницей количества воздуха, которое ушло наперед, и только ушло назад, и потом мы получаем какую-то определенную скорость воздуха и объем воздуха, который уже очищен от пыли. Работающая система обеспыливания при работе комбайна избирательного действия. Благодаря комбинированной системе обеспыливания, проветривания, мы видим, что машинисты и другой технический персонал находятся в зоне свободной от пыли. Вот как вы видите, вот, это, конечно, неправильно, он без каски, но видите, вся пыль уходит через всасывающий патрубок самого обеспыливания. И пыль находится как бы вот этой какой-то пробкой воздушной, она прижимается к груди забоя, и пыль не выходит за пределы рабочего органа комбайна. Так, следующее. Следующее это расчет параметров. Это расчет параметров, я вернусь обратно. Значит, так, это факторы для расчета подаваемого воздуха. То есть мы уже говорили об этом, значит, это очень важно. Размеры туннеля, подземной горной выработки, сечение, длина и другое. Способ проходки, наличие эмиссии отработанных газов двигателей, запыленность. Кроме этого, диапазон температуры, местонахождение, разветвление. И с этих каких-то основных данных мы начинаем рассчитывать нашу вентиляционную установку, которая необходима для вентилятора местного проветривания или для портальной вентиляции. Значит, здесь нужно обратить, то есть объем воздуха на месте эксплуатации зависит от использования машин дизель-КВ, о чем мы уже говорили. Рабочий персонал, о чем я тоже уже говорил. И здесь используемый материал имеется в виду химический состав газа после взрывных работ, то есть продукты сгорания после взрыва. Кроме этого, имеется в виду химический состав материала, применяемый во время работ по укреплению и креплению выработок, например, бетонные смеси, гидроизолирующие смеси и другое. Вот. Процедура действия – это расчет для самого неблагоприятного случая, для последнего метра горной выработки. Здесь в туннеле написано горной выработки в общем, контроль каждого метра горной выработки. И в результате мы получаем объемный поток воздуха в месте эксплуатации. Следующее, очень немаловажное и очень важное, это требования к вентиляционным трубам, по которым мы подаем свежий воздух или чистый воздух в груди забоя. Значит, здесь первое это тип трубы. Стальная, гибкая, спиральная, диаметр трубы, специальные формы. Есть овальные вентиляционные трубы. Значит, качество труб. Бывают бэушные трубы, бывают новые трубы. Многие поставщики труб, или, скажем, изобретатели труб, они имеют различные свои технические данные. Это имеется в виду утечки, способ крепления между секциями вентиляционных труб. Это тоже нужно учитывать. Длина горной выработки. Какой максимальной величины будет эта длина этой горной выработки. Кроме этого, нужно учесть, будут ли во время проходки горной выработки какие-то повороты, изгиба. Ну и кроме этого, немаловажно иметь в виду сужение, потому что иногда бывает, мы идем одним сечением горной выработки, потом мы переходим на другое сечение горной выработки, и там же у нас не получается разместить вентиляционную трубу определенного диаметра, и мы начинаем ее сужать, поэтому эти все потери давления, скажем так, которые здесь, это нужно тоже учитывать. Кроме этого, нужно еще учитывать следующие факторы, которые влияют на выбор, правильный выбор вентиляционной установки. Если вы здесь видите, это как пример при помощи тоннельно-проходского комбайна схема проходки. Вот здесь, имеется в виду здесь обеспыливатель, здесь накопительный вентиляционный труб, вентилятор. И вот эти два вот этих параллельно стоящих обозначения, это в данном случае устройства, которые охлаждают воздух, потому что строительство туннелей или горные вырубки бывают не только холодные, но и очень жаркие. Поэтому для этого нужно, чтобы создать благоприятные условия работы техник, людей, техники, необходимо охлаждать этот воздух, потому что невозможно работать при плюс 50, плюс 40 градусах постоянно. Что техника, что люди, что техника от этого страдают. Поэтому мы здесь еще берем в учет следующие факторы. Это обеспыливатель, потеря давления из-за фильтрующего элемента, о чем я говорил, потому что вот. Кроме этого, это охлаждение, потеря давления из-за теплообменника, это скажем так, это охладительная установка. А кроме этого, нам необходимо не только охлаждать поступающий воздух, но в частности нужно его и нагревать, особенно в северных районах. Окей. Поэтому все эти данные тоже нужно учитывать для выбора вентиляционной установки. То есть потеря давления при наличии обеспыливателя, потеря давления при наличии охладительной установки или потеря давления при наличии электрокалориферной установки. Из этих всех данных, о котором я только что говорил, значит, идет, то есть исходя из всего этого, мы берем все эти исходные данные, о которых я говорю, берем их в основу, и потом проводим расчет вентиляционной установки. Вот вы видите здесь на слайде, как это все происходит. У нас есть специальные программы, в которые заводятся все эти исходные данные, которые мы сами рассчитываем, или те, которые поступают от заказчика, потому что бывает, что тут наши нормы такие-то, и вот под эти нормы нам, пожалуйста, рассчитайте вентилятор и все остальное. Вот, поэтому мы все это заносим в нашу программу, и потом, это как пример, в данном случае, вот здесь как пример. И вот мы получаем какое количество воздуха нужно подать в груди забоя, какая общая потеря давления, в зависимости от вентиляционного става и дополнительного оборудования. И получаем мощность этого двигателя, который необходим для, скажем так, для этого типа вентилятора. Дальнейшее. Здесь мы потом, мы берем тогда эти все исходные данные. У нас есть специальные каталоги, то есть всей серии вентиляторов, которые выпускает наша фирма, и начинается подбираться, то есть оптимальный вариант этой вентиляционной установки. Ее немаловажная роль, что это кривая характеристики вентилятора, значит, вот здесь указано, это зона стабильной работы, здесь зона срыва потока. Ну, кто занимается вентиляцией, знает, что вентилятор имеет тоже такую точку, критическую точку, что больше не могут дать, и начинается срыв. То есть получается непроизводительная работа самого вентилятора. Вот. Это тут рассчитывается КПД вентиляционной установки, потому что зачем нам сжигать электроэнергию, если отдача этого вентилятора у нас минимальна. Поэтому это все оптимально выбирается. И на следующем слайде мы видим, это уже с нашего каталога, определенный тип вентилятора, который можно выбрать под расчетные данные. Это опять-таки как пример. И в данном случае был выбран вентилятор для взрывобезопасного исполнения АЛ-17-2000. Вот. В данном случае вот здесь мы видим, мы имеем в виду здесь тоталь, то есть потеря давления общая, которая состоит из P динамической, это потеря давления от движения воздуха по вентиляционному трубопроводу или же по дополнительному оборудованию, то есть электрокалориферы, охладительные установки, обеспыливатель. PST – это потери давления, возникающего в результате трения воздушного потока о внутренней стенке вентиляционного трубопровода или дополнительного оборудования. Вот. Ну и красная точка, видите, это расчетная рабочая точка вентилятора, и синяя точка, вот здесь выведена, это устанавливающая рабочая точка вентилятора. Вот. И я сейчас не рассказываю, какой вентилятор, к чему это нужно в каком-то индивидуальном разговоре, или мы можем об этом потом говорить, смотреть, что к чему и как. Поэтому все к этому я подхожу к своему финалу своей презентации, мы потом переходим на подведение итогов. Подведение итогов заключается в следующем. Результат расчета вентиляционной установки. Это определяется нужный объем свежего воздуха для каждой рабочей зоны. Проверить последующие рабочие зоны на наличие свежего воздуха. То есть сколько необходимо будет, если, например, будет проходка продляться дальше. Запланировать резерв на случай изменения рабочего процесса. Это тоже очень немаловажно. Применять вентиляционные трубы с наибольшим диаметром, если это позволяет. Вот. Удерживать давление в трубах в общепринятых пределах, то есть следить, если нет ли утечки, можно применять электрошкафы с прямым пуском, можно применять электрошкафы для управления софт-старта, то есть это плавного запуска софт-старт, или же применять электрошкафы со встроенными частотными преобразователями, что я считаю наиболее, как говорится, правильно, потому что горная выработка, она в один день не становится 1000 или 1500 метров, она вначале бывает 50, 100 и так далее. Поэтому при помощи частотного преобразователя мы можем регулировать подачу воздуха в груди забоя. Соответственно, с увеличением длины проходки мы увеличим производительность самого вентилятора и подачу воздуха непосредственно в груди забоя. Кроме этого, нужно еще обратить внимание на результаты по расчету звуковой эмиссии, потому что вентиляторы не создают какой-то шум. Соответственно. Поэтому по западноевропейским нормам в работе, то есть шум, создаваемый вентиляционной установкой в районе, где работает технический персонал, должны не превышать 96 дБ. Поэтому вентиляторы по своей конструкции являются источником шума, о чем я сказал. Необходимо дополнительные меры по понижению звукового уровня. То есть вентиляционные установки снабжаются шумоглушителями, кулисными, с внутренними содержаниями, то есть есть много разных видов. Следующее. Значение эмиссии указано в инструкции эксплуатации производителя. То есть каждый вентилятор имеет свою инструкцию эксплуатации, где стоит, что вентилятор при максимальной мощности его работы имеет уровень шума столько-то, столько-то дБ. Вот. Следующее, поэтому проверить место эксплуатации и наличие других источников шума или обратного воздействия местности. То есть, если, например, может быть где-то в горной местности, поэтому этот шум находится, возвращается обратно. Кроме этого, в случае потребности предусмотреть дополнительные меры. Это вкратце о вентиляционных установках и об обеспечивающих установках. И сейчас напоследок, то есть на конце моей презентации, хочу вам продемонстрировать анимационный фильм, который демонстрирует комбинированную систему обеспечения, местного проветривания и принципа очистки воздуха от пыли. Здесь находится вентиляционная установка, обеспечивающая установки, сама обеспечивающая установка. Здесь трубопровод от вентилятора местного проветривания, и вот это все создается так называемая пылезащитная стенка. Вы видите, что запыленный воздух уходит через всасывающий патрубок обеспечивающей установки. И пространство всей выработки свободно от пыли. Здесь продемонстрировано обеспечивание сухого принципа действия производства нашей фирмы. Здесь показано, как очищается воздух от пыли. Подробности мы можем, как в индивидуальном порядке, в рабочих группах об этом поговорить. И в результате мы получаем свежий воздух, свободный от всех частиц пыли, которые присутствуют в этом проходке.
Good afternoon, everybody. Thank you very much for your time. I appreciate it, and thank you to Sandra for inviting us here. I'm just going to start the presentation. After our presentation, we'll be splitting into 3 groups, and you guys will have the opportunity to actually see the product live and get a live demonstration outside in the parking lot. If we can start the video. want to just give you a little bit of an overview. So what I'll just introduce you to Faratech, our background, how we got into the simulation industry, also about the products and solutions that we have to offer, and the implementations that we've done around the world, or a sample of those. Beyond that, I just want to talk to you about 3 case studies, and then we can open up for some questions after that. So into the background of the business, we've been producing high fidelity full mission simulators now for over 20 years. We started in the military industry, and we supply a number of governments around the world, including most African, Swedish, Croatian, Australian defence forces all use our products on the military side of things. From this side, the technology lent itself very well to the mining fraternity, and ultimately 15 years ago we entered the mining industry. We've also more recently entered the civils and construction industry. Our company is ISO 9001 accredited, and all of our products are built to a MIL standard, a military standard. So in terms of the background to the company, our head office is located in Durban, South Africa. We do all of our own manufacture, both hardware, software there. And ultimately, we created a very large business for ourselves in Southern Africa. Beyond that, we've been on a global expansion strategy, first opening offices in Perth and infiltrating that market successfully for the Asia Pacific side of things. Toronto. From the Toronto office, we've opened up many sites in North America. Again, Santiago, Chile, done the same for South America. We are currently exploring both this market and the lower Asian market. And ultimately, we will have an office opening here in Moscow. Within the next month to service the CIS clients. If we take a look at our global customer set, or just a snapshot of it, 7 of the top 10 Forbes listed mining houses are using us as their de facto supplier with regards to the simulator implementation. The CIS market has fallen behind the rest of the world in the adoption of simulation. But we've seen a lot of interest over the last few months here, and we believe this market will come around to the idea of simulation very, very rapidly. Our head office in Durban, South Africa, in planning for our global expansion strategy, we've made sure that we've got ample production capabilities ready to cater to our clients' specific requirements. If we talk about the product range, I need to define exactly what it is that we do. We offer tools to the training organizations and the training sections of your mines to enable you to better train your operators. There are a number of tools, but anything from computer-based training, and this is really for very, very low-level introduction information to these 2 products are more honed towards new recruits. Ultimately, our full simulator, or full mission simulator, comes in 2 variants. One can be containerized and therefore transportable, and the other one being a fixed facility, which would be built into a classroom type environment. Both do the same thing basically. The product itself, I won't get into too much detail now. We've got one of these containers outside here in the parking lot, as I mentioned, so we will actually go through there in groups, and we'll describe this throughout everything. But just a high-level idea here now. We have an interchangeable cabin, or CAD, so you can run multiple pieces of machinery on one of these containerized base units. It has a full motion platform, full 360-degree screens. The idea is to immerse the individual in the most realistic environment possible. We use all OEM components. So, for instance, if it's a Sandvik DD420 like we have downstairs, you'll see that we've got the actual original equipment being used in that. So beyond the products and the implementation, why would one consider simulation? The idea is very, very straightforward when you think about it. We've spoken, there's been a number of presentations today about bucket fill factor and a number of equipment optimization ideas. Ultimately, the largest gain that a mine can get in this day and age is from a highly skilled, well-trained and honed operator. These gains are huge in comparison to the small percentages that can be gained by equipment improvements. If we talk about the actual side of things, increasing in productivity, we're able to track parameters within the simulator that you cannot track in the real world or are currently not being tracked in the real world, therefore allowing the operator to get a better understanding of his environment and how he can improve his production. If we go on to the safety side of things, we are able to simulate safety scenarios that you just simply cannot do in the real environment. You can't, and ultimately your operators can react better because they've now experienced it. And in terms of your maintenance costs, again, we are tracking parameters within the simulator that will highlight deficiencies in your operators' utilization of the machine, ultimately being able to improve or reduce your maintenance costs. Very important factor to this, we talk about a customized simulator. Our simulators are tailored to your exact environments. So beyond our replication of any of the OEM's machinery, we come and we actually replicate your mine, its road rules, its traffic patterns, anything along these lines to make sure that your operators, when they are training in as close as an environment as possible to your original mine, ultimately being able to give you a better trained operator. So if we talk about, we've talked about the product, but we can't just bring you a nice simulator, drop it off on site and say, there you go. Ultimately, it is one tool in a complete cycle or chain. We're looking to have a completely augmented training process and how everything fits into it. So, integrating everything with the mine, using the mine site's specific requirements, as well as any other regulatory body that's required for any local industry. If we have a look at what a complete training program looks like, the first thing, and this is something that we provide beyond our simulators, is really understanding your training and assessment strategy at the highest level. Beyond that, then creating the program curriculum to integrate all of the tools, right down to individual session planners. And this will vary quite dramatically whether you are training new recruits or if you are trying to hone the skills of an experienced operator. Ultimately, we can help you create a bespoke training solution to provide this. For instance, we might run through a complete group, and you may still get some issues from your maintenance personnel explaining that you've got a particular issue that keeps occurring. We can tailor this and address this in the training material, ultimately train out that solution, and then further down the track and make sure that the training is correctly implemented and you're getting results in the real environment. So this gives you a broad overview in terms of the product and solutions that we have to offer. And I'd like to go through 3 case studies with you. The first one is Newmont in Elko in Nevada. The second one will be Aslang Blackrock in South Africa, and the third one is an Xstrata site in Queensland in Australia. So just with regards to the Newmont pilot program, we entered this pilot program. It was done over a course of about a month. We were dealing with experienced operators. This was done on a dual boom drill rig. And ultimately, the issue that was identified on site was the blast pattern. These guys were not getting the blast that they required every time, and it was slowing down their entire operation, needing to bring in more machinery or equipment to clean up after every blast had happened. We were it was very easy for us to identify that the issue was actually that the operators were only being tracked on the speed at which they were drilling the holes rather than ultimately the accuracy in terms of pitch and yaw error. After being able to highlight this to the operators in terms of just how badly they had their pitch and yaw errors occurring, they were immediately able to correct this. These were very experienced operators, most with over 10 years of experience. They were easily able to correct this, but we know there was a very, very large drop in the speed because they were now taking the time to do the setup, making sure that every hole had been drilled accurately. Over the course of several more exercises, we were able, in most cases, to achieve within about 2 to 3% of the original speed, however, maintaining the accuracy. So a successful pilot of this, and ultimately Newmont has invested with us quite heavily since then around the world. After this pilot in North America, we actually asked these operators what their sense was in terms of the training. Now, bear in mind they had been through a number of traditional training means before adopting simulation. And we asked them what they thought of the simulator. And the first one really, did they feel the training was relevant? Yes, absolutely they did. It was a categoric yes. Would they recommend it? Yes, they did recommend the technology and they have since adopted it. And did they gain value from it? A number of other things with regards to the training. They gave us some extra input and feedback that they would like to have a system tailored further to their requirements. But ultimately there was buy-in from the operators, and this is critical for any training program to ultimately work. Again, we set up a pilot process with them, a pilot project with them. We did a site evaluation. We developed the training objectives with them, set the training schedule, effectively gathered the data after this, and presented the results back to mine management. We did this again on 2 vehicles. There was an LHD and a drill rig once again. So we ultimately had 4 sessions with the guys, and this was an interesting pilot for us because we ran an incentive program for the operators. So what you'll see in some of them, their errors actually increased despite having more training sessions, and this is because they were trying to achieve more tonnage throughout this duration. So just some small errors that occurred. So we applied accelerator and brake simultaneously. We see a dramatic decrease of this over the number of exercises that the guys did. And a number of these errors that were occurring had just been standard practice for the operators. Nobody had ever questioned them on their application of a brake, the brakes while accelerating or anything along these lines. They just learnt it, and it was a bad habit that just continued through all of the subsequent operators as they learned from one another. And to the point where we actually brought in the equipment manufacturer in this instance to come and have a discussion with the operators because they argued the point to us, explaining that our simulator actually had it incorrect. Ultimately, the manufacturer supported us in this, and we've subsequently changed a lot of their training programs since this. So just a few other errors, using the steering control levers and the brakes simultaneously. Again, you're seeing a marked reduction in these errors. So if we look at the holistic picture, over the complete duration of the pilot project, we were able to reduce the number of errors in the first session for all of them, 779 errors occurring. By the last session, it was 95, and I believe through a continued program, we could have reduced that even below those figures. If we overlay this over the production gains, we were able, in the simulator, to increase the total number of tons dumped by 70.5%. This is a huge, huge margin. Now, we can't expect to achieve anywhere near that in the real world, otherwise we would be billionaires. But ultimately, you would see at least a 10% of this figure realized in the real world as we've tracked through our figures. An important factor here, again, it comes down to our ability to track individual items that are just not feasible or possible to track in the real environment, and educating the operators for this. So again, another highly successful pilot. So these pilots have been pilots that we've run ourselves, but later I'll show you the Extrata one where we've actually left the site to run this themselves. Again, with regards to ASMAN, they had a dual boom drill rig, and once again, through a number of training sessions, we were able to improve the number of, or improve their setup time with the machine, improve the accuracy of their drilling, but ultimately also improve the speed and the number of holes that they drilled. All through, once again, an accurate representation of the real environment in the simulator. So if we go on to our third pilot project, this is the most recent one done by Xstrata. We effectively sent them the details that were required and asked them to perform a number of exercises with their operators and actually run through a standard pilot process without us actually monitoring it. So once again, a fairly similar process in terms of understanding the site's requirements. Having management buy-in and involvement is obviously critical. We need to be able to highlight exactly the improvements that have been made. Identifying the test subjects, which exercises we plan to do, and then identifying the vehicles. So in this instance, it was a Sandvik DD420, similar to the one here, as well as an LHD. The ADT details are not in this one. So again, ran through a fairly straightforward sample. The scoring metrics on the LHD, this is a generic set. The driving scoring, again, we've got a number of generic sets, but again, tailored in every instance. We've also got emergency situations and a number of other parameters that are tracked. This is the front end of the system. And beyond that, we can track an immense amount of additional information in the back end, which we can explain to you in more detail at the demonstration. So if we look at the LHD scores, and this is by individual over a series of 4 exercises and what we were able to achieve. Now I must note that we had limited amount of time with these guys, only 30-minute sessions. And ultimately, we find a 30-minute session, you can get enough information probably across on an LHD or do enough training. But when it comes to more complex pieces of machinery, something like a drill rig or bolter, really these machines require significantly longer durations for training. So if we look at castings here, again, total tons loaded, I had a 23% increase in that. Number of cycles completed within a designated time period. He managed to improve the number of cycles by 50% here. And the number of errors, again, reducing quite dramatically. Throughout all of these guys, there's I think 8 guys that we ran this test sample with. We have a significant improvement in the number of tons done and improvements in their cycles. So very, very good results on the LHD. Again, you find this machine, there are a lot of small parameters that are not being tracked in the real environment, that ultimately the operators just don't understand, or they don't appreciate how their small actions will ultimately mean far, far larger gains to the mine in the big picture. So a couple more exercises here done by Russell. I think this was one of the individuals who was maybe a slower learner, and this is a key part to the training. It needs to be tailored to every individual. We can't expect everybody to learn at the same rate, just as we wouldn't expect to see the same errors occurring across multiple individuals. We will find that some are just better than others. If you go right back to the recruitment side of things, or the early phase of recruiting your operators, the simulators also help you really identify who the key personnel should be operating on each machine. So you may find that some operators just don't grasp the concept of an LHD very well, and he may remain an ADT or an articulated dump truck operator rather than progressing through a career path. Again, back to the LHD. A couple of others. I'll just flick through a few of these so we get to the drill rig scenario. We will have 1 or 2 individuals who just don't perform, and it can often skew the results quite dramatically. This pilot process was done over quite a large number of individuals, and all of them actually achieving very, very reasonable results. So if we look at the LHD summary, it was actually split into two groups. Ultimately, we had the first group, Group 1, achieved a significant amount or a large increase in the total number of tons dumped, the total number of cycles, and they also managed to decrease the number of errors that they were making. If we look at Group 2, it's a little bit of a contrast in that they did ultimately, they were able to increase the total number of tons dumped, as well as improve the number of cycles completed, but their error rate increased quite dramatically. So in this instance, really this would require an additional level of training and addressing the underlying exercises, possibly pulling the gentleman out of whichever exercises they were doing, the operators, and putting them into more error or safety related exercises to help address the issues that were being caused, and then retest them on an overall exercise. So if we look at the concentration set of errors among each of these operators, some of the worst ones were, for example, use steering control levers while applying the brakes. Again, this is a machine maintenance abuse, and ultimately, by reducing the number of errors here, your maintenance costs should drop quite significantly. Again, spinning wheels while mucking, it becomes a tire wear issue. We've got a number of other productivity-related pieces of information that we can track along these lines. So, for example, bucket fill factor and all of these various things. Okay, so if we move on to something a little bit more complex now, the Sandvik DD420. As I mentioned to you, these operators were only doing 30-minute sessions, and I believe only 4 sessions on the simulators. Now, in this instance, I don't believe that was enough time, and we can actually see issues with regards to the guys actually getting worse as time went on. So ultimately, through this, we managed to improve the guys' drilling rate in terms of the number of holes that they were drilled, their setup time. From that perspective, we were able to increase that quite significantly. But we'll show you in the simulator, we have a number of training tools to enable the gentleman to better understand their drill accuracy. And as soon as these training tools were switched off, the pitch and yaw errors increased dramatically. So their accuracy of drilling was actually quite poor once these had been switched off. So ultimately, this just requires quite a bit more time with the individuals, and just as we said, back to similar to the Newmont process, just ultimately being able to spend the time to get the operators to a level of proficiency before removing the training tools, and ultimately just giving them the understanding with regards to pitch and yaw errors. As I say, we will be able to go through this in much more detail in the simulator and actually show it to you live, which is always a lot more interesting than listening to a few figures. All right, that's effectively the end of the cases. If you guys would like to ask any questions.